Alright guys, here's going to be our example video for related rates, and this is going to be a little bit of a longer video just because I am going to try to get through probably 5 to 6 examples is going to be my goal, just because like I said, related rates are a little bit more complicated. They're one of the harder topics in AP Calculus AB, and there are just a lot of different ways we can do them. So the first question says y equals x squared, and it wants us to find dy over dt. So how is y changing versus t when x is equal to 1 and y is equal to 2? And just going back to those 4 steps I told you guys about, first thing we want to do is to figure out what our givens are. So our givens are, I'm just going to write g for given, x equals 1, dx over dt equals 2, and we're trying to find dy over dt. And this is just going to help me stay organized. My second step is going to be to write the equation, which is y equals x squared plus 3. Then my third step, I'll do this in a new color. My third step is going to be to take the derivative. So that's d over dt, right? We're taking the derivative with respect to time. And then d over dt of this whole thing, so we have to distribute the derivative everywhere. Alternatively, you could have just written d over dt everywhere. Alright, so with that we get dy over dt, and that's actually, it's basically, right, the derivative of y is 1 times dy over dt equals 2x times dx over dt plus 0. So we'll just get dy over dt equals 2x dx over dt. And then we'll plug in our givens, which was x equals 1 and dx over dt equals 2. So we'll get dy over dt equals 2 times 1 times 2, which is 4. So in this case, our solution, dy over t, is just 4. Oh, and this was step 4, by the way. Sorry about that. Okay. So that was a really easy example, and that's, when they basically give us the equation. And, following this, a lot of the real-life examples, they're not going to give us an equation anymore. So I didn't really put this in the notes, but just very quickly, we could see volume, velocity, circles, area, perimeter, and we're going to have to take into account units, so meters, seconds, hours, minutes, everything. And just a few quick notes, I guess, would be things that we could see written, would be something like, say, the velocity of a car, right, something like that. And you just want to think, when we're writing our equations, we could say like x equals something, and this is going to be our distance, right? And then remember that when we take the derivative of that, we said that was the velocity. Alright, another thing could be a volume question. So a really typical one is we're filling up, I'll say, putting water into or out of a pool. And I put pool in quotations because this could be anything, like a rectangular pool, or it could be a cone or a cylinder. Right, a cylinder would be like a soda can, but just any example with liquid, really. And we're going to say V equals whatever, and this is going to depend on the shape. So like if it was a cylinder, it would be pi r squared h, and that's our volume. And then when we take the derivative dv dt, we take the derivative, and that would be our rate. And then lastly, there are more examples than this, but I'm just going to do kind of the 3 major ones. Would be something that's rotating or revolving. And this is usually a circular object, so like a tire or a gear or something like that. And if you're driving, you'll see in your car that RPM, which means rotations per minute. And so when we're rotating something in a circle, just a reminder, a circle is 360 degrees, or 2 pi radians, and in calc usually we use that radians one. And so we're thinking about the angle, so we would have theta equals, and that's our angle of, of where it's revolved so far. So, if it was pi, that means we went in half a circle. If it was pi over 2, we went in a quarter of a circle, right? Because a full circle is 2 pi. And you can think back to your unit circle. And then d theta dt, and that would be our, RPMs, right? If it's RPMs, but this is basically the rate of how fast it's rotating or revolving. So that's just, before we do the examples, I just wanted to talk about some things we might run into. So a first example could be something like, say you drop, so this will be example 2 actually, but our first real life example. Let's say you drop or you throw a rock into the pool. And you guys all know just from life, if you throw a rock into a body of water, it's going to ripple outwards. And all those ripples are circles. So, the question would say it ripples, and it makes a bunch of little circles, right? Bigger, 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 and bigger. And it would say that the radius of those circles, so as they get larger and larger, is increasing at some rate. So we'll say the radius is increasing at a rate of, why don't we say, 1 meter per second. And then it's going to say something like, when the radius is at 4 meters, what is the area of the water, either like inside the circles, inside the ripples, or it'll probably use some kind of weird terminology like, what is the area of the water disturbed or something like that, but basically just the water that was changed, right? So again, the reason I gave you that organizer and told you to do it step by step is because if you notice, there's absolutely no equation here. It just gives us a bunch of words, right? So we have to kind of identify, and things that I'm going to notice is we're making circles, right? So our ripples are circles, and we know that by radius or just because they're ripples. And then we know our given was that the radius is increasing at 1 meter per second, and then also when the radius is 4. So this is a rate, and this is 4. So anytime we see the word rate, we know that's one of the derivatives. So that's dr, right? The rate of the radius. So on top is what it actually is, and then on bottom is, because it's a rate, dt. And that's going to be 1, and let's include our units. So remember, this was step 1, our givens. So our givens are dr dt equals 1 meter per second, and our radius equals 4 meters. And then what are we finding? We're finding the area. Okay, step 2. Now we're finding an area, right? So even if we weren't finding an area, and if that was in the givens, we just want to think, what formula do we know for circles and area, because it talked about area. So I know that area equals pi r squared. And again, the hardest part of these questions, in my opinion, isn't actually doing the math. The math is usually easy. Taking the derivatives is easy. The hardest part is really the step 2. It's because you have to remember back to all those geometry formulas. So area equals pi r squared. And then step 3 is to take the derivative of that. So d dt, d dt. Pi is just a constant, right? It's just like having a 3 in front or 3.14 in front. So this is going to be 1 times dA dt equals 2 pi r dr over dt. And you'll notice this is right here, this is actually the circumference. Just something to note because sometimes a question might talk about the circumference. So finally, step 4 is now we're going to plug in our values. So we knew that r was 4 and dr dt was 1. So we're going to get dA over dt equals 2 pi r. Oh, and you know what? I kind of messed up this question. It should have said, what is the rate at which the area is disturbed? So what is the rate at which the area is disturbed, right? If it had just said what is the area, it would have just been area equals pi r squared, which is easy. So that was my fault. This should have said what is the rate. So we're not finding area, we're finding dA over dt because it's the rate of the area. So my mistake there. So anyways, dA over dt is going to be 2 pi times 8 times 1. And I actually want to add my units in here. So I'm going to say times, and it's not 8, it's 4. 2 pi times 4 meters times 1 meter per second. And then we're going to multiply out, and we'll get 2 times 4 times 1 is 8 pi meters squared per second. dA over dt. And don't really worry too much about those units, but just know that a meter times a meter, just like x times x is x squared, a meter times a meter is a meter squared, and then still per second. And we can leave our answer with the pi in it, just like in pre-calc. So that's the answer there. Alright, next question is going to be something like, let's do an example. You're inflating a balloon. So a question might say, you know, you go to the store and get your balloon filled up with helium, and you know, helium is filling a balloon at a rate of 4.5 cubic feet per minute, and we want to find the rate of change. This time, instead of area, let's do of the radius. When the radius is 2 feet. So now we do step 1, right? Identify our givens, identify the problem. So we have a rate of 4.5 cubic feet per minute, and it doesn't really tell us radius or whatever, but it does tell us that this is the rate at which helium is filling the balloon. So if we think about a balloon, right, it's a 3D, it's a sphere, and if helium is going into it, that's the volume. So even though it didn't specifically tell us, we have to figure out that this 4.5 is talking about the volume, and it's a rate, so it's how fast the volume is changing. So that's going to be dV over dt. How fast is my volume changing at 4.5 cubic feet means feet cubed per minute. So that's a given. My other given was the radius equals 2 feet. And what are we finding? We're finding find the rate of change of the radius. So we're finding dr, the rate of change of the radius with respect to time, because it's a rate. Okay, step 2 is to write our equation. Now again, we just want to think of what we're doing. We have a balloon and we have volume. So we're going to say you have to look up the formula for volume of a sphere, which is 4/3 pi r cubed. And again, we're just going to have to start memorizing these. So by the time we take the AP test, we need to know all of the volume formulas. So that's volume, right? Step 3 is dv dt, taking the derivative of this. So d dt and d dt. Okay, so we get dv over dt, right, or 1 times dv over dt equals, our 3 goes down, so 3 times 4/3 pi r squared dr dt. The 3's cancel, and now we're going to substitute in our givens. So step 4, right, this was 2 and that was 4.5. So step 4, dv over dt equals, oh, you know what, this wasn't 4.5, sorry, the volume, the change in the volume, right? So make sure we're plugging it in for the right thing. dv over dv over dt is 4.5. So now we get 4.5 equals 4 pi times 2 squared dr dt. I'm just going to add in my units because we want to have units. So this was feet cubed per minute, and this was just feet. Okay, so this is going to be 4.5 feet cubed per minute equals 2 squared is 4, and it would be feet squared, and 4 times 4 is 16 pi feet squared dr over dt. Okay, I can simplify. Both sides have a feet squared in it. So, and now I'm going to divide by 16 pi. And we're going to, in this case, since we have a decimal in here, usually if there is a decimal, you can just make your answer into a decimal. So I do 4.5 divided by 16 pi, and it's going to be about, like, approximately, when I round, 0.09 feet per minute, and that's equal to dr dt, which is what I was solving for. Okay, I'm going to shoot for 3 more examples, but at this point, if you kind of feel like you've gotten a solid idea of what's going on, definitely feel free to either keep watching and just watch TV in the background and come back to this later, or just come back to this later in general. But the other examples are going to be different types of situations, so they still might be useful. Example 4 is going to be a velocity example. So we'll do something like an airplane, and we'll have something like, an airplane. This is an example from your guys' book. An airplane is flying on a path that will take it over a tracking station. And they provided a picture on here. And they say, if S is decreasing at 400 miles per hour, when S equals 10 miles, what is the speed of the plane. And then they gave you a picture, and the picture had an airplane, so here's my beautiful airplane, and the airplane, here's our tracking station, and then the picture had S was here, X was there, and this was 6 miles. So it's at a height of 6 miles. And what you can kind of notice by this is X is our horizontal distance, right? And S is my actual distance from the tracking station. And so it's changing, it's literally, you know, it's flying this way. It's not going to crash into the tracking station. So X is going to be our distance that the plane's traveling, right? It's traveling in that kind of a direction. And so when we're thinking speed, right, speed is going to be dx over dt, because remember, speed was the derivative of the position of the x, of the distance. So when we do our, you know, our givens, so they gave us, right, givens, they gave us the 400 miles per hour, which was s is decreasing. So that would be ds dt equals, now the decreasing is important. Decreasing means it's not 400, but it's negative 400. And then they also gave us just s equals 10. And then we're trying to find the speed. What is the speed? Which is dx over dt. Alright, step 2 we said was to come up with some kind of an equation. Now, this is kind of tricky, but we want to look at everything they gave us, right? They didn't give us any equation. We go back here, no equation. But they did give us a picture, and this picture has a right triangle. So again, we're going to have to go back to geometry, and we're going to have to think when we have a right triangle, we do a squared plus b squared equals c squared, which in this case would be x squared plus 6 squared equals s squared. And we can't plug in s equals 10 yet, because as the plane gets closer, s is going to change, but the 6 is always going to be 6. It's the height. It's not lowering its height. Okay, so now step 3 is to take the derivative with respect to time, and that will give us 2x dx over dt equals 2s ds over dt. And now we can plug in our givens, which will be 2x dx over dt equals 2 times 6 times negative 400. Now, we ran into a problem, right? How can we solve for dx dt if we still have an x? Well, we can't. So let's go back and see if there's anywhere where we can figure out x. Now, the instructions definitely didn't give us any x. But what they did say is it was at a specific time. So it was at the time where s was equal to, right, s was equal to 10. So now we have a triangle with 10, with 6, and with x. So we can do a squared plus b squared equals c squared with 10. And what you want to think about when we're doing step 1 and 2, we're leaving the variables in there. Or sorry, step 2 and 3, we're leaving the variables there. But on step 4, you're plugging your variables in, so now we can go back here, and we can say x squared plus 6 squared equals 10 squared, and that's x squared plus 36 equals 100. subtract 100, we get x, or sorry, subtract 36, we get x squared equals 64, which gives us x equals 8. Alright, so now I'm going to come back in here and I'm going to plug in 8 for this x. And so we get 16 dx over dt equals 2 times 6 is 12 times negative 4. 12 times 4 is what? Negative 4,800. And then we're going to divide that by 16. And when you divide that by 16, we get dx over dt equals negative 500. And I forgot my units, so if you forget your units, just go back and plug them in. The S was in miles. Our negative 400 was in miles per hour. And then this 8, since we did a squared plus b squared equals c squared, and these are both in miles, x is also a distance, it's going to be in miles. So those will cancel, and we still have miles per hour. Okay, and it's negative because it's decreasing, which if we look back to our picture, our plane is going this way. It is getting closer, so this x should be getting smaller and smaller, which is why it's negative. So our answer does make sense to be negative. Okay, another example could be if we're doing something where our angle is changing. So maybe something like, again, I'll do another book example because they have some good ones with pictures. Find the rate of change in the angle of elevation of the camera, which is going to be in a picture, 10 seconds after liftoff. Now, they only gave us one given here, but the picture is going to have a second given. So, here's this little camera, and it's looking at a rocket, and so that makes a triangle for that angle of elevation. And the picture told us that theta was right there, and it said tangent of theta equals s over 2,000, and then they put 2,000 feet here. So they were a little bit mean because they didn't tell you where s was, but they did tell you where s was. You just have to figure it out. Tangent is opposite over adjacent, right? So opposite over adjacent, our theta's right here, so our opposite side is over here, which is where s is. So that means that s goes right there. Now, the only equation we have is this tangent theta. So when we get to step 2, we're going to have to use that for our equation. Alright, step 1 are givens, right? So givens, well, they gave us that s equals 10. They also gave us that 2,000, right, which was our horizontal distance. And then they did give us the equation, but I'm going to save that for step 2. Okay, and then we're finding, right, it says find the rate of change in the angle. So angle is d theta, and then rate we always say is over dt. Alright, step 2, write down our equation. We have tangent theta equals s over 2,000. Alright, step 3 is to do the derivative of that. So d over dt, d over dt, and the derivative of tangent is secant squared theta, and then times d Now, this is a little bit tricky, but the variable is theta, so it'll be times d theta over dt, and that's going to be equal to, now, this 2000 doesn't go away, it's just like a, 1 over 2000 s, so it's just like having a coefficient. So, the derivative of s is just 1, so this will be 1 over 2000 times ds over dt. Now, we don't really know what that ds over dt is right now, but what we need to think about is that, oh, you know what, okay, so actually this question, the book had a little note below the picture, and it said that the rocket is traveling with a height of s equals 50 t squared. Okay, so it actually wasn't s equals 10 from the question, it was 10 seconds, which would be t equals 10. So we can find ds over dt and we can find s by plugging that in to the equation in the picture. So I'm going to say s equals 50t squared, and so s equals 50 times 10 squared, which is 50 times 100, or 5,000. And then we're going to take the derivative, so we want to be able to find this ds over dt term. So to find the derivative, we're going to do d dt and d dt, so we'll get ds dt equals, now this is nice because we're taking the derivative of time with respect to time, so we don't have to do implicit. So it'll be 2 times 50 is 100 t, and we're going to plug in that 10 for t. 100 times 10 is 1000. So that's going to be what we're going to plug in for ds over dt. So going way back to that equation we had, we'll have secant squared of theta, and we still don't have a theta yet, but secant squared of theta times d theta over dt, which is what we're solving for, equals 1 over 2000. Now we're going to plug in that 1000. Okay, next we want to figure out what theta is, and in order to figure out what theta is, we have to use our equation, our original, which was tangent theta equals s over 2000. And now we do know what s is, right? We solved for s and we got 5,000. So we're going to say tangent of theta equals 5,000 over 2,000. And we'll have to use our calculators for this. And so we'll do the inverse, right? Inverse tangent and inverse tangent. And in this case, we're going to do the inverse tangent. And I'm actually going to have to look that up online really quickly because I don't have my calculator in front of me. So we get theta equals 1.19 radians. Okay, and then, so now we can plug that in for theta, and so now we do have everything except for what we're finding. So we'll have secant squared of 1.19 d theta over dt equals 1000 over 2000 is just 1/2. And then when we do secant squared, if you're typing that into a calculator, make sure you type in secant of 1.19 and then close your parentheses and then put the squared. And you'll get 7.24 about d theta over dt equals 1/2. And then we'll divide both sides by 7.24. And 1/2 divided by 7.24 is like 1 over 7.24. So we should get d theta over dt equals 1 over 14.48. And for units, because remember we have to remember our units, this is, if we put the units in here it'll get kind of confusing, but if you think about it's how quick is an angle changing, so that's going to be radians per, and time was in seconds. So if you ever get confused about what your units are, you can actually, whatever time they provided, seconds, minutes, hours, and then think about what that unit is. So it was radians per second. So that is our answer there. And if you want to put that into a calculator and give me a decimal, you guys can do that. Alright, one last example, and then we'll be done with this. And let's do an example from the homework I'm going to give you guys. So we'll do question 546 in your homework. Is going to be really difficult in those packets. And I forget what section that's from. I think it's 2.13. But number 546. And it says the area of an equilateral triangle is increasing at 5 meters squared per hour. And then it says find the rate at which the height is changing when the area is 64 over square root of 3 meters squared. And you can look at that example in your guys' homeworks or those packets. And kind of the big thing here is that equilateral triangle. And so you want to draw yourself a picture. They didn't give you a picture, you want to draw a picture. Equilateral triangle means every side is the same. So I'll have x, x, x. And I didn't do a good job of making that look like an equilateral triangle, but we get the point. And so we want to think about first, what were our givens? Well, our givens were that we had the area is increasing, right? So the area is increasing, that means it's a rate. So dA over dt equals 5 meters squared per hour. And then the second given was the area equals 64 over radical 3 meters squared. And then we're finding the rate at which the height is changing. So dH, because it's the rate of the height, over dt, because it's a rate. Okay, step 2 is to get an equation, right? So we know we have area. We know it's a triangle. So we're originally going to say area equals base times height over 2. Now, the main problem we're going to have with this is, you're going to have to do dA for step 3. We're going to have to do dA over dt equals, and then if you try to do it like this, we're going to get a product rule, and when we multiply by this derivative, we're going to get a term of dB over dt. Well, we don't have anything about the base or how the base is changing, so we want to try to fix that. And we actually can, because the height here, and this is again geometry, you really have to remember your geometry for these questions. Okay, an equilateral triangle, what you have to remember is all of the angles are 60 degrees, and then this height cuts it in half, so that's 30 degrees and 30 degrees. And then you have to remember your 45, 45, 90 triangles and your 30, 60, 90 triangles. So 30, 60, 90 triangle I'll draw it kind of a little bit bigger. We have 60 here, we have 30 here. Now this side here is going to be half of x. So I'm going to write that as x over 2. And then that's across from 30. So across from 60 is that times radical 3. So it would be x over 2 radical 3. And that is equal to my height. Right, so that's my height, and my base is x. So I'm just going to plug. Now I don't want to plug both of those in, right, because we're eventually solving for dh over dt. So we want to have h in there. But what I'll do is just off on the side, I'll put h equals x over 2 radical 3, and base equals x. Now, what we're going to do is we want to find dh over dt. So instead of putting these into terms of x, I want to figure out what the base is equal to. So I need to solve for x, like, solve x in terms of h, and then I can figure out the base in terms of that. So I'm going to solve this h, right, and I'll multiply by 2 over radical 3 times 2 over radical 3 to solve for x in terms of h. And we'll get 2h over radical 3 equals x, and that's what the base is equal to. So we can say the base is 2h over radical 3. So this is a really confusing question because we just, you don't want to have two terms here that we don't know. We want to get them both to be h since we were eventually solving for dh over dt. So we change this b to be 2h over radical 3, and then we're going to leave the h the same because that's what we wanted, over 2. Okay, so that's my new equation, and we can actually try to get rid of the fractions in here. So we'll multiply by radical 3 on the top and radical 3 on the bottom. And since this is all multiplying, those will just cancel. And we get area equals 2h squared over 2 radical 3. Those cancel. And then we would get h squared radical 3 over 3 would be completely simplified. Okay, now step 3 was to take the derivative. So d over dt, d over dt. So we get dA over dt equals 2h radical 3 over 3 times dh over dt. And we're almost done. Our last step is just to plug in all of the givens. So our first given was the area at which the rate at which the area was changing, which we had called 5. And then the height, we had said that they didn't give us a height yet, right? But they did give us the area, so we need to find this. So we'll say 5 equals 2h radical 3 over 3 dh over dt, and then we'll figure out what the height is. So they did give us an area, so we're going to go back to our area formula, which we said was area was equal to h squared radical 3 over 3. And I'm actually, because if you notice, the area they gave us was 64 over radical 3. Well, since there's a radical 3 on the bottom, it would actually be easier to solve this with that part of the formula before we simplified it. So I'm going to say that our area is actually equal to h squared over radical 3. You don't have to do that, but if you notice that, it'll just easily let you simplify that by canceling out the radical 3's. and then we'll square root both sides and get 8 equals h. So now we're going to plug in 8 there, and we'll get 5 equals 2 times 8 radical 3 over 3 times dh over dt. And that's 5 equals 16 radical 3 over 3 dh over dt. And we're solving for dh over dt. So I'll multiply both sides by the reciprocal 3 over 16 rad 3, 3 over 16 radical 3, and we'll get 3 times 5 is 15 over 16 radical 3 equals dh over dt, and then that's 15 radical 3 over 48. And I think I actually made a mistake somewhere here. I solved this a long time ago, and we got this answer, which is the answer in at the end of the book. We have h squared over radical 3. I just left it there. I didn't actually simplify that, which made it easier. But yeah, dA over dt equals 2h over radical 3. 5 equals 2 times 8 over radical 3 dH over dt. And we get this answer. So if you can see where I made my mistake and tell me on Monday, I'll give you some extra credit. But yeah, this should be the answer. So if you want to look through how I solved it initially without my explanation, you can look through that. And if you can tell me where I made my mistake on this problem, I'll give you some extra credit on Monday. Alright, have a good weekend, guys, and I'll see you on Monday.